Today we're going to work on lesson 5.1, solving systems of linear equations using a table and graphing. You should have your notebook out. You should have a piece of graph paper that you can use. And feel free to pause the video anytime you need to. So this goes in your notes, please. These two definitions. The first one is system of linear equations. This is what we are working on. It's a set of two or more linear equations in the same variables. We are going to be doing two equations with the variables of x and y. Eventually, you will get more equations and more variables, 3 and 4, but that's not until high school. The second definition is the solution of a system of linear equations. This is an ordered pair that makes each equation true. We're going to start by graphing, and so we're going to graph two equations, and the point where they intersect is that solution, and later on we will be doing it algebraically. So we're going to start with this example. Your family starts a bed and breakfast in your home. You spend $500 fixing up a bedroom to rent. Your cost for food and utilities is $10 per night. Your family charges $60 per night to rent the bedroom. So we're going to write two equations. The first one represents our costs. So we spend $500 fixing the bedroom up, and then it costs another $10 a night for food and utilities. So $10 per night is our slope. So we're going to write it in slope-intercept form, y equals 10x. And then we spent $500 before anything in order to fix up the bedroom. So we're going to add that as our y-intercept. So our first equation is y equals 10x plus 500. Then we're going to write our second equation, which represents our revenue or our income. And we charge $60 a night to rent the bedroom. We don't start with anything, so we're not starting with a profit or anything like that, so we do not have a y-intercept. And $60 per night would be our slope. So y equals 60x and no y-intercept. So what I want you to do is pause the video, copy and complete this table. We're going to put our cost, which is y equals 10x plus 500 on this row, and our revenue, which was y equals 60x on the bottom row. The top row is our x. That's how many nights we are renting the bedroom out. So go ahead and complete the table, and then tell me when we break even. When do we make just as much money as we are spending? Pause the video, fill out the table, and then come back and see how you did. So 0 nights, we still spent our $500, and then we go up by 10. So 510, 520, 530, 540, 550, 560, 570, 580, 590. Here we have 600 and 610. How much we make at 0 nights, we didn't make anything. And then we go up by 60s. So 60, 120, 180, 240, 300, 360, 420, 480, 540, 600, and 660. So when do we break even? If you look at night number 10, we had both spent $600 and made $600. So night 10 is when we broke even with $600. And if we put that in form of a point, it would be 10,600. And that is our solution. If we had to graph it, our first equation, y equals 10x plus 500, we would start at our y-intercept, which was 500, and then we would go up by 10s every single night. So this one kind of goes up a little bit. There's 10, 20, 30, 40, and then we're right on 50, 60, 70, 80, 90. There's that, and we would keep going up like this. Then we're going to graph our second equation, which was our income or our revenue, y equals 60x. So again, that starts down here at 0 because we do not have a starting point. We don't have a y-intercept, or we do at 0. And we're going to go up by 60. So there's 60, 120, 180, 240, 300. I'm just kind of making guesses here. It's going to be close. And then we're right there. So we're like that. So if we look, and you guys will be able to make better straight lines on your graph paper, hopefully with a ruler. But if we go up, our two lines are going to cross right at that 10 nights and $600. And that's what we're looking for. You're going to graph two lines, which you already know how to do, and find where they intersect. So here's your first problem, and we'll do this one together. I'm going to use two different colors for my equation. So the first one is going to be y equals, basically this is 1x minus 5. So our y-intercept is negative 5, and our slope is 1. So we're going to go up 1 to the right 1, and we're just going to keep on going. I'm not going to draw a straight line. I'm just going to make points all the way through. You have a ruler, you're going to draw a straight line. Then we're going to do blue. We're going to use that for our next one. So our slope is negative 3 over 1. Our y-intercept is 7. So 1, 2, 3, 4, 5, 6, 7. Here's our y-intercept. I'm going to go down 3 to the right 1. Down 3 to the right 1. Down 3 to the right 1. And I could keep on going, but I have my solution. My solution is right here where the two lines crossed. This is 1, 2, 3, negative 2. And that is our solution, the one point where they cross. And we can even double check our answer. This is our x, this is our y. We could plug it in. What's 3 minus 5? That equals a negative 2, which is our y. So that checks out. Negative 3 times 3 gives us negative 9 plus 7 equals a negative 2, which also checks out. It's one simple way we can check our work. This one, same thing. Graph your two lines. We have our first one, which would be a negative 1 plus x plus 2. So we have a y-intercept of 2. Now we have negative 1, so we're going to go down 1 to the right. Down 1 to the right 1. Down 1, right 1. And I'm going to keep on going all the way through my graph. And, of course, you guys will use a ruler or some sort of straight edge and draw the line. Now, before we can do this second equation, we need to change it into slope-intercept form. So I'm going to add 3x to both sides. So I get y equals 3x minus 10. So negative 10 is my y-intercept. 3x, I'm going to go up 3 to the right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And I'm going to stop right there because there's our solution, which is 1, 2, 3, negative 1. And there's our solution. It's as easy as that. Graph your two lines and tell me where they cross. However, it can't always be that easy, so let's talk about this situation. You invest $500 for equipment to make dog backpacks. Each backpack costs you $15 for materials, and you sell each backpack for $15. We're going to do the same thing as before. We're going to figure out our equations. So we have for revenue, or for cost rather, y equals, let's see, we're selling them for 15. So 15x plus the $500 we started with. Our income, we're selling them for $15 a piece, so 15x. And again, we didn't start with anything. I can fill in the table. At 0, I spent 500. And I'm going to go up by 15s. Up, and I'm not going to do the whole thing because hopefully you're kind of looking at it already thinking this doesn't exactly work. We're going to do 0, we're going to do 15, 30, 45, 60, 75, 90. If you look, these two lines are never, ever going to cross. When are we going to break even? Never. We are never going to break even. So the reason we can tell is we have two equations that have the exact same slope. And you guys already know that if you have the same slope, the two lines are parallel. So here's a case in point. You don't even have to graph this. If you look at your two equations and you see they both have the same slope, no matter what they're going to look like, and I'm just going to draw two quick ugly lines, they're going to be parallel. They're never going to cross. They are not going to have a solution. This is a no solution problem because the two equations will never ever cross. Here's another example. I already have my first equation in slope-intercept form, so let's change the second equation into slope-intercept form. I'm going to subtract 4x from both sides, so I get 2y equals, I'm going to put negative 4x plus 8. I'm going to divide by 2, so I get y equals, that would be a negative 2x, and this would be plus 4. Now, if you look, this equation is the same as that equation. So that means if I graphed it, it would look something like that, and the other line would look exactly the same. I did a really bad job, but you're going to get the exact same line, which means every single point on that line is going to be a solution. I call that all solutions. Next page, you're going to put this in your notes, please. So again, we have three different types of answers. The first one is one solution. You're going to graph the two lines. That one point, you're going to give me the XY coordinate as the solution. That is going to be most of the problems that you do. The second one is going to be no solution. If they have the same slope, that is going to mean that they're parallel. There's no solution. You don't even have to graph those. The third one, infinitely many solutions or all solutions, is what am used to calling it. And that's if you have the exact same equation all the way through. Same slope and same y-intercept. So you can go ahead and look at these two problems and try them out. Go ahead and look at these two problems and try them out. Your homework is the 5.1 worksheet. I gave a paper copy in class, but there's also a PDF of it in Schoology, and this one is due during next class, the beginning of next class. So if you have questions, let me know. Otherwise, good luck.